In 4.1, there are three definitions. The first one is a sector, and that's a part of a circle bounded by two radii and an arc of the circle as shown here. The two radii, the arc, and this is the sector. A central angle is an angle formed by two radii of a circle. That's one radius, that's the other, and this forms the central angle. And a radian, that's the measure of the angle formed by rotating the radius of a circle through an arc equal in length to the radius. So here's the arc length, and it's equal to the radius length, and this is also the radius. So this angle right here is equal to 1 radian. The key concepts for 4.1 are that the radian measure of angle theta is defined as the length A of the arc that subtends the angle divided by the radius r of the circle. So the formula is theta equals arc length over radius. To convert degree measure to radian measure, multiply the degree measure by pi over 180 radians. To convert radian measure to degree measure, multiply the radian measure by 180 over pi degrees. And when converting from radians to degrees, you need to know that 2 pi equals 360 degrees, or pi equals 180 degrees. Okay, this is an example for converting radians and degrees. For this one, we have to convert degrees to radians, and it's 85 degrees to radians. Remember that to convert degrees to radians, you have to multiply it by pi over 180. So we do 85 times pi over 180 degrees. Not degrees actually. So then that equals 85 times pi over 180. That's about 1.48 radians. Now to convert radians to degrees, we need to times it by 180 over pi degrees. So 1.1 times 180 over pi degrees. And that equals about 63 degrees. 63 degrees. This question is about arc length of a given angle, and it says a circle has a radius of 25 centimeters and has a central angle of 4.5 radians. So let's just draw an angle, and that is 4.7 25. And it says determine the length of the arc that subtends this angle. So we know that the arc, that theta equals arc length over radius. So we know that theta is 4.75, and we don't know A, and the radius is 25. So we just have to multiply 4.75 by 25 to find out the arc length. So A equals 118.75, 118.75 centimeters. That's this. A. For 4.2, we need to know and remember the trig ratios. So this is a right angle triangle. This is theta. So this is the opposite side, adjacent side, and hypotenuse. Sine of theta is opposite over hypotenuse. Cos of theta is adjacent over hypotenuse. And tan of theta is opposite over adjacent. To remember this, you can just remember the abbreviation SOHCAHTOA. Now for the reciprocal trig ratios, it's just the reciprocal of each trig ratio. So cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. We also need to know the cast rule and special triangles. Cast rule is when it's C, A, S, T. Quadrant 4 is C, quadrant 1 is A, quadrant 2 is sine, and quadrant 3 is tan, therefore cast. And this means that C, cos is positive in quadrant 4, A, all of them are positive in quadrant 1, S, sine is positive in quadrant 2, and T, tan is positive in quadrant 3. The special triangles are the same as last year, but instead of degrees, we now use radians. So sine of pi over 4 would be opposite over hypotenuse, 1 over root 2. Sine of pi over 3 would be opposite over hypotenuse, root 3 over 2. We need to remember this for this part of the chapter. The key concepts for 4.2 are that you can determine the reciprocal trig ratio for an angle expressed in radians, measure by first calculating the primary trig ratios and then taking the reciprocal of that answer. You can use the unit circle and special triangles to determine exact values for the trig ratios of special triangles, and you can use the unit circle along with the cast rule to determine exact values for the trig ratios of multiple of the special angles. So we're going to apply trig ratios for our special angles, and it says to calculate A in exact values. So this is A. We have pi over 6, 45 centimeters here, 50 centimeters here. So we need to calculate this. This is the opposite. So we can either use this value, which is adjacent, or hypotenuse. I'm going to use the hypotenuse, so opposite over hypotenuse. That's sine. So we're going to do sine pi over 6 equals opposite over hypotenuse, so A over 50. So if you times both sides by 50, you'll get A. So A is equal to sine pi over 6 times 50. And that will equal and we know that sine pi over 6 is sine, so it's opposite, 1 over 2. So it's 1 over 2 times 50, so it's half of 50. So it's 25 centimeters. There are two definitions for 4.3, and the first one is equivalent trig expressions, and that's equations that have the same solution. An example is sine x equals cos pi over 2 minus x. This means that sine x is equal to cos pi over 2 minus x, no matter what value. And the next definition is a trig identity. A trigonometric equation that is true for all values of the variable for which both sides of the equation are defined. The same equation is also a trig identity, because for any value of x, sine x will always equal cos pi over 2 minus x. The key concepts for 4.3 are that you can use a right triangle to derive equivalent trig expressions that form the cofunction identities. You can use the unit circle along with transformations to derive equivalent trig expressions that form other trig expressions, and that given a trig expression of a known angle, you can use equivalent trig expressions to evaluate trig expressions of other angles. This is a list of all the equivalent trig ratios that we have learned. Use equivalent trig expressions to evaluate primary trig expressions. Given that sine pi over 4 equals 1 over root 2, calculate cos pi over 4 in exact values. So we know that sine x equals cos pi over 2 minus x. So since we need pi over 4, we can say this is equal to cos 4 pi over 8 minus 2 pi over 8, because that equals pi over 4 inside the brackets, and that's what we need. So then we can also say that this is equal to cos pi over 2 minus pi over 4. Since we know that pi over 2 minus cos pi minus x equals to sine x, this is also equal to sine of pi over 4. That is equal to 1 over root
It's 3 o'clock.
2.